Hello everyone, welcome back to yet another tutorial video. If you're new to this channel, welcome. My name is Jason. I post coding tutorial videos just like this one on my channel. So if you enjoy this video, please consider subscribing. You'll greatly help my channel grow as well as help my content reach a wider audience. Now today I'm extremely excited because today I'll be sharing my notebook for my first ever Kaggle competition, or even just my first machine learning project in general. So if you don't know what Kaggle is, essentially Kaggle is this online community platform for data scientists and machine learning enthusiasts. On Kaggle, you can find stuff like published datasets, tutorials to help you get started with machine learning, but most importantly, Kaggle is best known for their competition, which is what we're going to look at today. There are many company-sponsored competitions on Kaggle where you can compete with other people to win cash prizes, but that's not the main focus for today. Today, we're going to look at a more sort of introductory competition that's suited for those of you who are keen to gain some hands-on experience with a machine learning project, or even those of you who are looking to make your first submission to Kaggle. So I personally think Kaggle is an amazing platform with a bunch of good resources, whether you're trying to learn data science or if you're trying to learn machine learning. So if you haven't already checked out Kaggle, I highly recommend that you do so. Today we're going to look at a very classic beginner's project on Kaggle, which is the Titanic Survival Prediction Competition. Now we have quite a bit to get through in today's video, so without wasting any more time, let's just jump right into the notebook. Alright, so what you're looking at now is Jupyter Notebook. Is what I like to use to do my analysis on. It's what I personally recommend that you do as well, because with Jupyter Notebook it allows you to run your code cell by cell, which I think is very useful when you're doing data analysis. Just do a quick Google search, Anaconda Jupyter Notebook. You should be able to find some instructions on how you can install it onto your computer, so I'm not going to go through it in too much detail. So the aim of this competition is very simple. Given what we know about the passenger on the Titanic, can we predict whether or not this passenger has survived? Or in other words, we want to train a machine learning model to learn the relationship between passenger features and their survival outcome, and subsequently make survival predictions on passenger data that our model has not seen before. Now, I know that sounds a bit of a mouthful, but we will get a better understanding of this project as we go through this notebook. And before I get started as well, I think it's important that I outline the datasets that you typically find in the Kaggle competitions, starting with the training set. So training set is a dataset that we'll be working on predominantly. This is where we'll be performing our manipulation and analysis to extract insights as well as build a predictive model. The goal here is for us to determine and create features that will help us predict the outcome of our data, and in our case is predicting the outcome of the passengers as survived or did not survive. There are two main types of problems in machine learning, and they are classification and regression. Titanic is an example of a classification problem, and more specifically, this is a binary classification problem where we're trying to classify a passenger as either survived or did not survive. So there are two main categories. I'll potentially do a video on a regression project in the future, but essentially how regression differs from a classification is that the outcome is continuous rather than a discrete outcome. So our model needs to be able to predict and classify the outcomes as either one of two categories, survive or did not survive the Titanic. Alright, now moving on to the test set. Once our model has been built, we need to make sure that it does not merely fit our training set, but also able to make predictions on out-of-samples data. Now, what out-of-samples data is the data that our model has not been trained on, or in other words, the data that our model has not seen before. We will use the test set as inputs to the model that we've built and make predictions based on those inputs. This is where you will be assessed in the competition, i.e. how accurate is your model at predicting new observations. It's also important to note that every competition has different metrics in which they assess model accuracy, and you can find this information under the evaluation tab of the overview section of the competition page. And for this competition specifically, the Titanic Survival Prediction Competition, the evaluation metric is simply the percentage of passengers that are correctly predicted by our model. And last but not least, we have the sample submission. So sample submission is nothing more than just a reference for you to structure your final data frame for submission. This is the format in which you want to submit your final solution to Kaggle. Therefore, it's important here that we pay attention to the column headings as well as the shape of the sample submission. If we submit a data frame that's in a different format than the sample submission, Kaggle will actually return an error, and it won't be able to evaluate our performance and our results. Alright, so this is the official Kaggle page for the Titanic Survival Prediction Competition. Where you would find the dataset is under the Data tab. And there is a description that walks through what I've just mentioned about the training set, the test set, as well as the sample submission. On there, you can also find a data dictionary which explains the features or the columns in that data frame, which we'll go through a little bit later. So all you need to do is just scroll down until you see this download all button. just hit that button, download the assets into your computer, and then go ahead and import that into Jupyter Notebook, and you should be ready to work with it. So before I forget, you will be able to find this notebook up on my GitHub. I'll make sure to put a link in the video description. So to start our project off, we're just going to go ahead and import the libraries that we're going to use in this project. Libraries are essentially extensions in Python that consist of functions that we'll be using to perform our analysis. And I've grouped the libraries according to their functionalities. So for data wrangling, we have pandas, numpy, missing number, and collections. And next, for data visualization, we have seaborn and matplotlib. Machine learning models, so these are the classifiers that we're going to use to classify the passengers as either survive or did not survive. We'll have a closer look at these models later on in the notebook. Next, we have model evaluation, which is what we're going to use to evaluate the performance of our model. Next, we have hyperparameter tuning, which we'll have a look later on as well. And finally, we're just going to remove all the warnings. Alright, so once we've done that, we want to import and read data. So there are three data sets, as I've mentioned in the introduction: the training set, the test set, as well as the sample submission. And the way you would read a CSV file is via the read CSV function that's in the pandas library. And I've assigned the training set to the variable called train, the test set as the variable called test, and finally the sample submission as SS. And now let's have a look at the first 5 rows of the training set. And the way you would do that is via .head. And this shows you the first 5 rows of the training set. So each row in our data frame represents a passenger on the Titanic, and going across the columns we have the different features that describe these passengers. So starting from all the way on the left, we have passenger ID, survive, which takes the value of 0 and 1, P class, the name of the passenger, sex, age, SIP-SB, PAJ, ticket, fare, cabin, and finally embark. Now we're just going to look at the first 5 rows of the test set as well. So notice the test set looks almost identical to the training set, except if you look closely, we have a survive column that's missing. So the test set does not have a survive column. And if we check the shape of both the training set as well as the test set, we should see that our training set has 891 rows and 12 columns. As for the test set, we have 418 rows and 11 columns, which is 1 less column than the training set, and that missing column is the survive column. And so the reason why the test set does not have a survive column is because survive is our response variable, or sometimes called a target variable. So it's our job to analyze the data in the training set. We're going to use the training set to build a model, and then use that model to predict the data in the test set, which is why the survival column in the test set is missing. And last but not least, let's have a look at the sample submission. So this is the first 5 rows of the sample submission. And if we check the shape of the sample submission, there are 418 rows and 2 columns. So the sample submission has the same number of rows as the test set and 2 columns, and the 2 columns are passenger ID and survive. And so if we scroll up and have a look at the passenger ID in the test set, they should correspond to the sample submission. So in the test set, we have passenger ID going from 892 down to 896 in the first 5 rows. And this is exactly the same as what we have in the sample submission. And we have a second column called survive. So the survive column is actually the predictions that will be made by our model. And so what we want to do with the final data frame that we're going to submit to Kaggle is to make sure that it has the exact same shape as our sample submission, with 418 rows and 2 columns, and the 2 columns are passenger ID and the survive column. Alright, so now let's go through the data description. So what I'm going to go through now is just the definitions of the features or the columns in our data frame. Starting with survive. So survive, if it takes the value of 0, that tells us that passenger did not survive. If survive has the value of 1, that tells us that passenger did survive. So P class is the ticket class, where 1 is first class, 2 is second class, and 3 is third class. This can also be seen as a proxy for socioeconomic status. And so what that means is passengers that belong to the first class probably indicates that they are a wealthy individual and they have a higher socioeconomic status in comparison to the second class as well as the third class. Next we have sex, which is pretty self-explanatory. We have male and female. Age is age in years. We have SIP-SB, which is number of siblings or spouse aboard the Titanic. Next, we have PAJ, which is number of parents or children aboard the Titanic. Ticket is the passenger ticket number. Fare is passenger fare. Cabin is the cabin number. Embark is the point of embarkation. Embark has 3 different values, C, Q, and S, each representing a different location a passenger can embark from. Now we're going to move on to exploratory data analysis, also known as EDA. EDA is the process of visualizing and analyzing data in order to extract insights. Firstly, we're going to examine the data types, missing data, as well as summary statistics. The function we're going to use here is .info, and we're going to apply it to both the training set as well as the test set, and the output should look something like this. Range index here tells us the number of rows in our data frame. So here we can see that the training set has 891 rows. And data column shows us how many columns are there in the data frame. So for the training set, there are 12 columns. So going down the rows, we have the names of the columns in the training set, starting from passenger ID all the way down to embark. And across the columns, we have non-null count, which is the number of values in that column. And next we have D-type, which stands for data type. So for example, passenger ID has 891 non-null count, which is the same number as the number of rows in the data frame. That indicates there's no missing values in that column. And passenger ID has int 64 as its data type. The age column, on the other hand, only has 714 non-null count, which is less than the number of rows. That tells us that there is missing values in that column. And for age, the data type is float64. Next, we're going to look at how we can compute for missing data in the training set. And the way you would do that is via isNull.sum. And we want to analyze the training set. And what I've done is sort the values of the missing data going from highest all the way down to the lowest. And the way you would do that is by setting the ascending argument to false. That will help you sort the values going from highest to lowest. So for the training set, as we can see here in the output, the cabin column has the most number of missing values at 687, followed by age at 177. And finally, we have the embark column, which has 2 missing values. And we're just going to do the same to the test set. Again, apply the isNull.sum function, this time to the test set. And we want to sort the values from highest to lowest by setting ascending to false. So again, cabin has the most number of missing values at 327. Age column has 86. And fare has 1 missing value. An alternative way you can do this is via the missing no.matrix function. This is what I personally like to use. It gives you a quick visualization of where your missing data is in your data frame. All you need to do is pass in a data set, and in this case we want to pass in our training set into the function, and the output should look something like this. So a missing value is represented by a white line. So as we can observe here in the output, we can see here that the cabin is severely missing with a lot of missing values. Age also has quite a substantial number, and finally the embark column has 2 missing values. So there's 1 missing value here and 1 missing value here. And as for the test set, again, we want to pass in the test set into the missing no.matrix function. And judging from the output, again, cabin has a lot of missing values. Age also has quite a number of missing values. And finally, the fare column has 1 missing value. And as for summary statistics, we want to use the .describe function. And so this is the output. Going across the columns are the columns in the data frame, or the features in the data frame. And going down the rows, we have the different statistics. We have count, mean, standard deviation, the minimum value, 25 percentile, 50 percentile, 75 percentile, and lastly, we have the maximum value. Now we're going to move on to feature analysis. So as the name suggests, feature analysis is simply the process in which we analyze the features in our data frame. And before we move on, I think it's also important to note the difference between a categorical variable as well as a numerical variable. Categorical variables have values belonging to one of 2 or more categories, and there's usually no intrinsic ordering to these categories. A perfect example in the Titanic dataset is the sex feature. So every passenger is distinctly classified as either male or female. Those are 2 very distinct classes, and there's no intrinsic ordering to it. Numerical variables, on the other hand, have a continuous distribution, and some examples are the age and the fare features. Now you might be wondering why it's important for us to make the distinction between a categorical variable and a numerical variable. Well, the answer to that is because it will help us structure our analysis more properly. And I'll give you an example. For instance, it doesn't make sense for us to calculate the average of a categorical variable such as gender, because gender is simply a binary classification and there's no intrinsic ordering between male and female. So it doesn't make sense for us to calculate the average between male and female because there's no such thing. Numerical variables, on the other hand, have a continuous distribution. So for example, we can calculate the average age of a passenger on the Titanic, and that's because age has a continuous distribution as well as an intrinsic ordering. Alright, so what we're going to do now is actually split the features in our data frame up into categorical variables as well as numerical variables and analyze them individually and see how they correlate with survival. Beginning with the sex column, the function that I like to use to analyze any categorical variables, especially when there's only a few categories in that column. For example, the sex column, we only have male and female. Value counts function is very useful in giving us a sense of the distribution of the values in that column. And I've also set the drop NA argument to false. This tells value counts to show me any missing values in that column if there's any. And so as you can see here, there are 577 male passengers on the Titanic, and there are 314 female passengers on the Titanic. So there are more male passengers than female passengers on the Titanic. Next, we're going to go ahead and compute the mean of survival by sex. The way we'll do that is via the pandas function called group by. So we're going to group the survived column by sex, and we're going to apply the mean to the survived column. And what I've done is actually sort the values of the mean of survival, going from highest to lowest. As we can see here, I've set the ascending argument to false. So female passengers, as we can see here in the output, have a drastically higher mean of survival than male passengers. And a possible reason for this is because female passengers were prioritized during the Titanic evacuation. And if you manage to watch the movie of the Titanic, this should make perfect sense because in the movie, women and children were prioritized during evacuation. And so what I've done next is use the bar plot function in the Seaborn library to just simply plot the mean of survival. So this is simply a visualization of this data frame we have up here. So as you can see here, female passengers have a higher survival probability than male passengers. Now we're going to move on to P class, which is the ticket class. So again, we're going to use the value counts function, and then we're going to apply it to the P class column. And in the output, we can observe that most of the passengers on the Titanic belong to the third class. The third class has the most number of passengers at 491, followed by first class at 216. The second class has the least number of passengers. And so next, we're just going to repeat the process as we did with the sex column, but now compute the mean of survival by passenger class. And so what we want to do is group the survive column by P class, apply the mean to the survive column, and sort the values going from highest to lowest. So this tells us that first class passengers have the highest mean of survival, followed by the second class, and third class passengers have the lowest mean of survival. Alright, let's try to rationalize this result. Why does first class passengers have the highest mean of survival? So a possible reason for this is similar to how female passengers were prioritized over male passengers during evacuation. We can guess that maybe first class passengers were prioritized during evacuation over the second class passengers as well as the third class passengers, resulting in first class passengers having the highest mean of survival. And again here I've used a bar plot to visualize this result. So as you can see here from the bar plot, first class passengers have the highest survival probability, followed by the second class, followed by the third class. I've also managed to analyze both the sex as well as the P class features together and see how they correlate with survival. There are two conclusions that we can make from this plot. The first conclusion is that female passengers always have a higher survival probability than male passengers, and this is indicated by the orange bars always being taller than the blue ones. The second conclusion that we can make from this plot is that first class passengers always have a higher survival probability than second class, and second class passengers always have a higher survival probability than the third class. And the way I drew that conclusion is from the fact that the bars in the first class are taller than the bars in the second class, and the bars in the second class are taller than the bars in the third class. Alright, so now we're going to move on to the final categorical variable, which is embark. Again, we're going to repeat the process. Value counts applied to the embark column. So as you can see here in the output, the most frequent value in the embark column is S at 644, C 168, Q 77, and there are two missing values in the embark column. And again, we're going to compute the mean of survival by point of embarkation. And in the output, we can see that location C has the highest mean of survival, and location S has the lowest mean of survival. And using a bar plot, we can visualize this result. And so survival probability is the highest in location C and the lowest in location S. Now let's think about this result for a second. Is there a reason behind this occurrence? We can formulate a hypothesis whereby the majority of the first class passengers have embarked from location C, and because first class passengers have the highest survival probability, this have contributed towards location C having the highest survival probability. Alternatively, we can make the hypothesis that maybe the majority of the passengers that have embarked from location S are from the third class, and because third class passengers have the lowest survival probability, this have caused location S to have the lowest survival probability among all the other locations. Now let's go ahead and test this hypothesis. And so what I've done is use a factor plot to plot the relationship between embark as well as the P class. And judging by this factor plot, our hypothesis appears to be true. So as we can see here, location S, which has the lowest survival probability, the majority of the passengers that have embarked from location S belong to the third class. And location C, which has the highest survival probability, the majority of the passengers that have embarked from location C belong to the first class. And because first class passengers have the highest survival probability, this has resulted in location C having the highest survival probability. And finally, what I've done here is plot the relationship between all the category variables, so embark, P class, and sex, and see how they correlate with survival. I'm not going to go through this final plot. You can take your time to analyze this plot yourself and see if you can spot any trends. Alright, so now that we've done analyzing the categorical variables, we're going to now move on to numerical variables. So the numerical variables in our dataset are the SIP SP, Paj, age, and fare columns. So there are 4 numerical variables. So first, what we want to do is detect and remove the outliers in numerical variables. Outliers are essentially data points that have extreme values and they do not conform with the majority of the data in that column. It's important for us to address the issue of outliers because outliers tend to skew our data towards the extremes, and this can cause our model to make inaccurate predictions. So I've written a function here that takes in 3 arguments. First is the data frame itself. N here represents the number of times a data point is deemed as an outlier. And finally, the features, which are the numerical variables that I want my function to detect outliers from. So what this function does is go through all the numerical variables, detect the outliers, and return the indices of the rows that contain those outliers. What I'm going to do is pass in my 4 numerical variables into my function, and my function has returned 10 indices that contain outliers. And using the load function in pandas, we can have a look at those 10 rows that contain the outliers. And what I'm going to do next is drop those 10 rows from the training set. And so before dropping our outliers, our training set has 891 rows. After dropping those 10 rows, we have 881 rows left in our training set. A good way to analyze numerical variables is by looking at the correlation that they have with our target variable, which in our case is the survive column. And so what I've done here is visualize the correlation between SIB-SP, Paj, age, and fair with the survive column using the heat map function in the Seaborn library. The ANOT argument here, I believe, stands for annotation. So by setting this to true, this tells the function that we want to show the correlation coefficient in the plot. FMT simply represents how many decimal places we want to show the coefficients. So in this case, I've set the coefficients at 2 decimal places. And CMap is where you can play around with the different colors of that heat map. And so this is the output of our heat map. The way you would analyze a heat map is either going across vertically or going down horizontally. So for example, if we want to analyze which features correlate with the survive column the most, we can either look at the survive row, which is the first row, or we can look at the survive column, which is the first column. So notice how a diagonal of a heat map all have values of 1, and that's because the correlation between a feature and itself is simply 1. And you can also think of the diagonals as a mirror between the 2 triangles. So we have the lower triangle and the upper triangle, and both the triangles should contain the same set of information. Alright, so now let's analyze which feature correlate with survive the most. So judging from this first column here, we can see that fair has the highest correlation coefficient. This tells me that fair is positively correlated with survival, or in other words, if a passenger pays a higher fare, the passenger will have a higher probability of surviving the Titanic. This makes sense, right? Because this is very much aligned with the P-class feature which we've analyzed earlier. So first-class passengers have the highest mean of survival, and we would imagine a first-class passenger pay a higher fare for their ticket, so a higher fare corresponds to a higher survival probability. Alright, so now we're going to look at our first numerical variable, SIB-SP, which is defined as the number of siblings or spouse on the Titanic. We're going to repeat the process as we did with categorical variables. Firstly, apply the value counts function. Next, compute the mean of survival. And then we're going to use a simple bar plot to visualize this. Next, we have Paj, which is the number of parents or children on the Titanic. Again, use the value counts. Compute the mean of survival. And use a simple bar plot to visualize this. And so next we have age. So there are 170 missing values in the age column. Unfortunately for age, value counts is not an appropriate approach for us to analyze its distribution. This is because value counts is only useful when our column only has a few categories, whereas the age distribution spans across a wide range of values. As you can see here from the disk plot, age starts from 0 all the way up to 80. So a better way to analyze the passenger age distribution is using this plot, which is again part of the Seaborn library. And so this is the distribution of our passenger age. We can also split the age distribution up by survival. So this is the age distribution for passengers that did not survive the Titanic. This is the age distribution for the passengers that did survive. And we can stack the 2 plots on top of each other to have a closer look. One thing we can clearly observe from this plot is that passengers that are of younger ages are more likely to survive. And again, this is largely due to the fact that just like women, children were prioritized during the evacuation of the Titanic, causing them to have a higher probability of surviving. Alright, so now we have our final numerical variable, which is the fare column. Again, using this plot, we want to examine the distribution of the fare column. So as you can see here from the disk plot, the fare distribution is very highly skewed. And we will have to address this issue of skewness later on via something called a log transformation, because just like outliers, skewness also affects our model performance, causing our model to make inaccurate predictions. But we'll have a look at that later, and so this wraps up our exploratory data analysis. Alright, so that brings us to the end of the exploratory data analysis section of this notebook. Through this process, we managed to gather some pretty useful insights about our passengers, as well as how the different features affect the survival outcome of these passengers. Let's now do a quick recap of what we managed to figure out. So there are three main points that we can conclude from our analysis. Firstly, we know that female passengers were more likely to survive than male passengers. This is because female passengers were prioritized over male passengers during the evacuation of the Titanic. Secondly, we know that first-class passengers have a higher mean of survival than the second-class as well as the third-class passengers. Again, this is due to the fact that first-class passengers were prioritized over the second-class as well as the third-class passengers during the evacuation, causing them to have a higher mean of survival. This has also in turn caused the fare feature to have a positive correlation with survival. This is because we know that first-class passengers pay a higher fare for their ticket, and because they have a higher mean of survival, this caused the fare feature to be positively correlated with survival. Last but not least, we know that passengers that are of younger ages, especially children, were more likely to survive than passengers that were of older ages. This is because, just like women, children were also prioritized during the evacuation of the Titanic, causing them to have a higher chance of survival than the other passengers. So I've made the decision to keep the data pre-processing as well as the modeling section of this notebook in a future video because I didn't want this video to turn out too long. But I do hope you enjoyed this video and found it helpful. Drop a like on the video, let me know what you think. And do subscribe to my channel as well because I'll be posting the part 2 of this tutorial very soon. That is all from me for now. Thank you so much for watching. Take care, keep learning, and I look forward to seeing you in my next tutorial. Bye.